Welcome back. Let's proceed from where we left. Mass from amount. This is the process of determining the mass of a sample of a substance based on the number of entities, such as atoms, molecules, or ions, in the sample. For example, if you know that you have 2 moles of a substance, you can calculate the mass of the sample by multiplying the number of moles by the molar mass of the substance. Example: if the molar mass of a substance is 18 grams per mole, and you have 2 moles of the substance, mass equals 2 moles, x, 18 grams per mole, equals 36 grams. Amount from mass. This is the process of determining the number of entities, such as atoms, molecules, or ions, in a sample of a substance based on the mass of the sample. For example, if you know that you have a sample of a substance that weighs 36 grams, you can calculate the number of moles of the substance by dividing the mass by the molar mass of the substance. Example: if the molar mass of a substance is 18 grams per mole and you have a sample of 36 grams, amount equals 36 grams, 18 grams per mole, equals 2 moles. Molar mass from mass and amount. This is the process of determining the molar mass of a substance based on the mass and amount of a sample. For example, if you know the mass of a sample is 36 grams and the amount of the substance is 2 moles, you can calculate the molar mass of the substance by dividing the mass by the amount. Example: if the mass of a substance is 36 grams and the amount of the substance is 2 moles, molar mass equals 36 grams, 2 moles, equals 18 grams per mole. Percentage composition in a compound is the determination of the percentage of each element in a compound by dividing the mass of the element by the total mass of the compound and multiplying by 100. Example: a compound made of 40 grams of carbon, 6.4 grams of hydrogen and 53.6 grams of oxygen. We can calculate the percentage composition of each element as percentage of carbon equals 40. 40 plus 6.4 plus 53.6, 100 equals 42.24%. Percentage of hydrogen equals 6.4. 40 plus 6.4 plus 53.6, 100 equals 6.72%. Percentage of oxygen equals 53.6. 40 plus 6.4 plus 53.6, 100 equals 50. Empirical formula of a compound is the simplest ratio of the atoms of each element in a compound. It can be determined by finding the number of moles of each element present in a compound, and then dividing each number by the smallest number of moles. Example: a compound made of 40 grams of carbon, 6.4 grams of hydrogen and 53.6 grams of oxygen. We know that the molar mass of carbon is 12 grams per mole, hydrogen is 1 gram per mole and oxygen is 16 grams per mole. We can calculate the number of moles of each element as moles of carbon equals 40, 12, equals 3.33 moles. Moles of hydrogen equals 6.4, 1, equals 6.4 moles. Moles of oxygen equals 53.6, 16, equals 3.35 moles. The smallest number of moles is for hydrogen, which is 6.4 moles, so we divide the number of moles of each element by 6.4. 3.33 moles of carbon, 6.4 moles equals 0.52. 6.4 moles of hydrogen, 6.4 moles equals 1. 3.35 moles of oxygen, 6.4 moles equals 0.52. The empirical formula for the compound is CH2. Determining the empirical formula requires you to know the molar mass of each element to convert the mass to moles and then finding the simplest ratio of the atoms of each element. Where will I apply this concept? I am glad you asked. The concepts of molar mass, mass from amount, amount from mass, percentage composition, and empirical formula are widely used in the field of chemistry, and have many real-world applications. Here are a few examples of where you might apply these concepts in real life. In the food industry, percentage composition and molar mass are used to determine the nutritional value of food products. In the pharmaceutical industry, percentage composition and empirical formula are used to identify the active ingredients in drugs. In materials science, molar mass and empirical formula are used to determine properties of different materials, such as their strength and durability. In environmental science, molar mass and percentage composition are used to determine the amount of pollutants in air and water, and to design methods to remove or reduce these pollutants. In forensic science, molar mass and percentage composition are used to identify unknown substances found at crime scenes. In agriculture, molar mass, mass from amount and amount from mass are used to determine the amount of fertilizer and pesticides required for a certain area. In meteorology, molar mass and mass from amount are used to determine the amount of pollutants in the atmosphere, and how they affect air quality and climate. In fuel industry, molar mass is used to determine the density and quality of different fuels. These are just a few examples, but the mole concepts are used in many other fields as well. That concludes our video on Introduction to Mole Concepts. We hope you found it informative and helpful. If you did, please give it a thumbs up and consider subscribing to our channel. Your support helps us create more content like this, and make it more accessible to people like you. We also encourage you to leave a comment with your feedback or any questions you may have, and we'll be happy to respond. Thank you for watching, and we hope to see you in our next video.